All right, if you haven't yet, go ahead and turn in your notes to 2.4. Today we're going to talk about multiplying rational numbers. I'd like us to look at this first section, number 1. Here's what it says. Without multiplying, tell whether the value of the expression is positive or negative and explain your reasoning. So I don't want an actual answer for this one. I just want to know, is it going to be a positive or is it going to be a negative? Let's look at that very first one. -4 times -2. Raise your hand if you think it's going to be a positive. Raise your hand if you think it's a negative. All right, I see a bunch of people saying positive. Can someone explain to me why this would need to be a positive? Luke, what do you think?
Because when you're dividing and multiplying, you don't take the sign of a larger number. You see how many negative signs there really are. So there's 2.
You are correct, okay? So let's write this down. An even number of negative signs will always equal a positive answer. Excellent job, Luke. Okay, so remember for this one, we are just counting how many negative signs we see there. An even number will always give us a positive answer. All right, let's look at the next one. We have a positive times a negative. Class, what kind of an answer is this going to be?
Negative.
It will be a negative, okay? And who can explain to me why we have it a negative answer? Michaela. You are correct. She told us there's only one negative sign and one is an odd number, so we know our answer has to be negative. So we're going to write this. An odd number of negative signs will always equal a negative answer. All right, for this next section, I would like you guys to pull out your red pens and go ahead and fill in this section. All right, so these ideas that I'm about to share with you are very important. You're writing it down with your red pen, and then I want you to go ahead and draw a red fluffy cloud around all 3 of these ideas, because this is the main thing I want us to take away from today's lesson. Okay, so if you look at this, the very thing that we see at the top is you do not need to find a common denominator when multiplying or dividing fractions. So when we've been working on adding and subtracting, we always had to find a common denominator. So multiplying, in my opinion, is actually easier because you don't have to find a common denominator. The next one, read me what it says in blue. Go ahead. Just remember, any time that you have a mixed number, you're not allowed to multiply it. Instead, you must do what? We have to turn them into an improper fraction first, okay? And then at the end, it says, if it starts as a mixed number, the final answer must be a mixed number, not an improper fraction, okay? Does anyone need more time on this slide? All right, go ahead and put your red pens up at the top of your desk, and now we're going to work through a few examples of this right here, okay? Let's say here, find the product and write the fractions in simplest form. Do I need to find a common denominator, yes or no?
Yes. Wait, yes.
Did you see what we just wrote up there at the top of our notes?
Oh, no.
Read me the first thing. You do not need to find a common denominator when multiplying or dividing fractions. So instead, all we're going to do is we'll just multiply across the numerator, and then we'll multiply across the denominator. So let's start with the numerator. Class, what's 1 times 3?
3.
3. Very good. Now we're going to focus on the denominator that you see right here. What is 5 times 8?
40.
40. Can 3/40ths be reduced?
No.
No, there is nothing that goes into a 3 that also goes into a 40, so the correct answer is 3/40ths. Go ahead and box that in. Looking at problem B, am I allowed to multiply mixed numbers? No. What do I have to do to the mixed number?
Make it improper.
We have to make it improper. So directly underneath it, if you guys would, write -1/3. What does it mean when I have these parentheses next to each other? It means to multiply, okay? So now we're going to go ahead and change that mixed number into an improper fraction. What would that be, guys?
11/4.
Okay, 11/4. And is that a positive or a negative?
Negative.
It was a negative, so we have to keep the negative right there. Okay, do you guys remember anything about cross-reducing when you're multiplying, cross-multiplying?
Yeah.
Yes, okay, so can I reduce 1 and 4 at all? No. Can I reduce 3 and 11 at all? No. So since I cannot reduce those at all, I'm just going to multiply across. Michaela, what's 1 times 11? 11. And now remember, we're going to go ahead and go down to the denominator. Autumn, what's 3 times 4? 12. Jace, I have a negative times a negative. Is my answer going to be positive or negative? It is going to be positive. Very good. So the correct answer is 11/12. Any questions on how we multiplied those together? Okay, for the next one, I am multiplying a negative decimal times a positive decimal. What is my answer going to be? Negative or positive? It has to be negative. Okay, very good. Let's go ahead right now and multiply these together. 2.5 times 3.6. When you are multiplying, you never have to line up the decimal points. Interestingly enough, they actually did line up here, but for the future, you don't have to line them up. Here's what you do have to do, though. I want you to pull out your red pen. If you look at this, there was a decimal point here, but it moved over 1 time over there. So what I want you to do is put the number 1. That simply means you had to move the decimal point over 1 spot. If you look at this next one, we also moved it over 1 spot. With your red pen, I want you to put a little 1. Now let's draw an arrow together, and I want you to add those two together. 1 plus 1 is 2. What this is telling me is when I get to my final answer, I will have to move the decimal point 2 spaces. Okay? I want you to take your red pen, put it back up at the top of your desk. Let's go ahead and multiply this together. 5 times 6. 30, 0 on bottom, 3 on top. 2 times 6.
12.
Plus 3.
14. 15.
15. I'm finished with the 3. I'm going to cross it out. What do I put as a placeholder?
0.
0. 5 times 3.
15.
5 on bottom, 1 on top. 2 times 3.
6.
Plus 1.
7.
7. Now we're going to add these together. 0 plus 0?
0.
5 plus 5.
10.
0 on bottom, 1 on top. Add those together, and what do you get? 9, okay? Now look, this little thing right here told me move the decimal point 2 places to the left. 1, 2, and you get 9.00. Class, is it going to be a positive or a negative? We talked about it already because if you come back over here, there was only 1 negative, so my answer has to be a negative. Am I allowed to just box it in down here? No, I want you to rewrite it somewhere. And do I need to keep the negative 9.00? No, you can get rid of that 0.00 and your final answer is just negative 9. All right, moving on to the next one. I'm multiplying a negative times a negative, so my answer will be a positive. Very good. Now we have 0.51 times 1.8. Should I line up my decimal points? No, you do not need to. Instead, let's count the decimal points. How many did this one move to the left? 2 spaces. How many did this move to the left? 1 space. Add those together. What's the answer? 3. So we know at the end we are going to move the decimal point 3 places. Let's multiply this together. 1 times 8?
8.
5 times 8?
40.
40. Put the 0 as a placeholder. 1 times 1?
1.
5 times 1?
5.
Add these together. When you add it together, what do you get?
Negative.
Okay, 918. How many places do I need to move the decimal point over? 3 places, 0.918. Do I need to keep this as a negative or make it a positive? It's going to be a positive because there were 2, okay? So I'm going to write it off to the side. 0.918. Guys, is that a terminating or a repeating decimal? It was terminating because it ended. And if we were to read this the proper way, it would be 918 thousandths. Very good job. All right, for the next section, it says to use number properties. Just remember, number properties are a shortcut. It's a way for us to do something faster. And we're going to use the number properties to multiply. Before I move on, I am looking at this original problem, and one of them is a whole number. I would like them all to be a fraction. If I made the negative 7 into a fraction, I could put it over the number 1. Very good. So let's do that to start with, over the number 1. Now, you could multiply all the numerators, find an answer. Then you could multiply all the denominators and find an answer. Then you'd have a big number, and you would need to go ahead and at that point start reducing, okay? But there is something I'm going to teach you about a shortcut. Before I move on to teach you, I don't want you to write this down, so just put your pencils down for a minute. I want to teach you about something called a reciprocal. Everyone say reciprocal. Okay, so the reciprocal of 3/4 would be 4/3. What this means is you can flip the numerator and denominator and get the reciprocal. You could have another one. If I had, let's say, 4/5, what would that reciprocal be?
5/4.
5/4. Very good job. Now, let's say that I had the reciprocal of 9/10. What would that be?
10/9.
10/9. If I were to add in parentheses, what does that mean I'm doing to those two? Multiplying. Now remember, we've got something that you can cross multiply. What would those 9s become? They would both become 1s, okay? And what would the 10s become? They would both become 1s. If you're multiplying 1/1 times 1/1, what is your answer?
1.
Okay, it could be 1/1, which as you said, equals 1. Okay, so you want to know that idea as we move on with this shortcut. Let's start first with this -1/7. Does anybody see the reciprocal of that in our original problem? What is it, guys? -7/1. You can bring down this little dot, or you could just bring down parentheses. It means the same thing. I still have a couple other fractions that I haven't brought down yet. One of them is 4/5, so I'm going to bring down multiply by 4/5. And there's one more. What's the last one I still need to bring down? -1/2. Because remember, guys, every number has a sign, and that sign is directly in front of that number. Good job. So we will bring down the -1/2. All we've done here is we've changed the order of our original problem. I haven't done anything else aside from switching the order. Okay, once again, that's that number property, the commutative property that says I'm allowed to change the order. I'd like you to take your pencil and underline this right here. We're going to work from left to right. I'd like us to multiply those two together. Is there anything that can be cross-reduced?
Yes.
The 7s. What can those 7s become? 1s. Very good. As I'm focusing only on this part that I've underlined here, that's a negative times a negative. So my answer will be positive. What is -1/1 times -1/1? It is just a 1. Everyone bring a 1 down. At this point, I need to take the rest of the things that I have on that line and drop them down. So I am multiplying it times 4/5 and multiplying it times -1/2. Anytime you multiply something by the number 1, it equals itself, right? So you really could pretend that that multiply by 1 is not even there. So now what I'd like us to do is to focus on this right here. Can anything be cross-reduced there?
Yes.
Which ones?
4, 2, and 4.
2 and the 4. What does the 2 become?
1.
A 1. What does the 4 become?
2.
A 2. As I'm working this out, I'll put a little equal sign here to the left. Let's focus on the numerators. What's 2 times 1?
2.
2. Let's focus on the denominator. What's 5 times 1? 5. Here we were multiplying a positive times a negative. Your answer has to be?
Negative.
Has to be a negative. And then remember, you're multiplying all of that by the number 1, which means you equal yourself. Can -2/5 be reduced at all?
No.
No. There's nothing that goes into a 2 that also goes into a 5, so our correct answer is -2/5. Looking at problem B, do you see any reciprocals there, class?
Yes.
Yes, okay. I want the reciprocals to be next to each other. They're like best friends, okay? So in this shortcut, I'm just going to switch the order of those last two. Once again, you can put the little dot, or I like to put parentheses. Multiply by 3/2. What do I still need to do with this part right here? I'm going to bring it down, okay? So bring that down here, and I'm multiplying by 7 7/8. Let's focus on this first part here. Can anything be cross-reduced?
Yes.
Yeah, we can cross-multiply all those things there, and they're all going to turn into ones, aren't they? Now I am multiplying a negative times a positive. My answer will be a negative. And what is all this big old mess? Negative 1. Drop down the negative 1. Is there anything else that needs to be dropped down?
Yes, 7 and 7/8.
All right, so do I just bring it down like this? 7 and 7/8?
No, the parentheses.
Why do I need the parentheses? That's what tells us to multiply. Good job. Now, Luke, I am multiplying a negative times a positive, which means my answer has to be negative. So what's my final answer? What is 1 times 7 and 7/8?
7, 8. Negative 7 and 7, 8.
Very good. Okay, we already knew it was a negative, and then anything multiplied times itself always equals, or anything multiplied times the number 1 always equals itself. So the correct answer is negative 7 and 7/8. Okay, for our modeling real life problem today, it says a school record for the 40-meter dash is 15.24 seconds. If we were to read that properly, what would that say? 15 and 24 hundredths. Excellent. Okay. Predict the school record after 15 years when the school record decreases by 0.06 seconds per year. Predict. What does that word mean? Guess. It's an educated guess. Very good. Okay, so we're going to make our best guess of what we think the record is going to be in 15 years. So I am going to use Jocelyn here because she has done track before. So we're just going to pretend that she has the record at Trinity for the 40-meter dash above everyone else, 15.24 seconds. Now let's imagine that one day she grows up, she gets married, and she has a kid. Her kid comes to Trinity, and in 15 years, are you going to have a boy or a girl? A boy. She says her son in 15 years is going to break her record of this. So it's our goal today to predict or make an educated guess of what his new record will be for the school. Okay, so we're going to start with a verbal model. With this verbal model, that simply means we're going to write words of what it is that we are doing. So if everybody would please write this down. The current school record. That's what we're going to start with. From there, we are going to add in the number of years down the road it's going to be when her son will change the record for our school. Now there's a couple of words that I want you to focus on that are going to help give you a clue of what to do anytime you see these in a problem. Up at the top at the end, you'll see per year. Anytime you see that little word per, it means you have to multiply. So in this case, we are going to multiply that by the yearly change that happened. So now that we have a verbal model of what it is that we're going to do, we're going to plug in the substitution. Everyone say plug it in, plug it in.
Plug it in, plug it in.
So down here at the bottom, instead of writing the words current school record, what was the current school record that Jocelyn has?
15.24.
Very good. Everyone plug that in directly underneath, 15.24 seconds. Plus the number of years down the road that her son is going to make a new record. How many years away is that? 15. Now remember, we have these parentheses here for a reason. Why do we have those parentheses there? We need to multiply. Those words per year tell us we have to do it per year. How much is it decreasing per year? 0.06. Now, I don't need that first 0. You can let that disappear and just put 0.06. It tells us that it decreased by that much. If something is decreasing, is that a positive or a negative?
Negative.
Very good. So that means this needs to be multiplying it by a negative 0.06. Here's what you could have done. You could have started with 15.24 and minused 0.06, and then minused 0.06, and then minused 0.06. How many times would I need to minus 0.06? 15 times, but there's an easier way. We know we have to multiply those together, so that's why it says to multiply. According to PEMDAS, we are going to multiply before we add. So off to the side, I want you guys to multiply 15 times 0.06. Go ahead and do that on your own. All right, so as I walked around, I saw a lot of people got the correct answer. Okay, it was 0.90, but remember, when you're multiplying a positive times a negative, your answer will be?
Positive.
Negative. A positive times a negative means it's going to be negative 0.90. Then what do I need to do with that 15.24 and the plus sign? I've got to bring it down, okay? Then you'll see I have a plus next to a minus. Who always wins out of positive negative? The negative always wins. So I can eliminate that plus sign because when I'm adding a negative, that simply means to subtract. Now I have 15.24 minus 0.90. Do I need to line up the decimal points?
No.
Yes. Anytime you add and subtract, you have to line up the decimal points. You don't have to if you multiply, but adding and subtracting, you do need to. So let's put this off to the side, 15.24 minus 0.90. You guys do that on your own. When you subtracted, what did you get?
Negative 14.34.
Okay, I saw some people had positive 1434 and some had negative 14.34. Look back over here. Same sign, add and keep, different signs, subtract, and take the sign of the larger number. Should it be positive or negative?
Negative.
It should be positive. The negative number that you see there is smaller, and that's why your answer should be positive. Okay, now it's a modeling real life problem, so I need units attached at the end. I want you to look carefully to see if you can figure out what those units would be. Okay, some people said seconds, some people said seconds per year. Here's what it asks you. Predict the school record. The record right now is 15.24 seconds. So the answer should be 14.34 seconds. I'm not asking seconds per year. If you notice up here, it already told us how much it decreased per year. I want to know what the new record is. So the new record would be 14.34 seconds. Okay? And that is the end of our lesson for 2.4.